Good morning students. This is the third video on this chapter factorization of algebraic expressions. In this video we will see how to rearrange or regroup the terms. Okay. So if the terms are not common, you have to rearrange it. How it is? Let's see. So first we'll see factorize by grouping suitable terms. So what are suitable terms? Look at this example here. A square plus bc plus ab plus ac. So here we see that near a square there is no a term. So we have to rearrange the terms. So where it is ab is a term is present or ac is a term is present, one of the term you make it near to the a square, so that it will be regrouped. So how it is? Equal to a square plus ab plus bc plus ac. So here we have rearranged or regrouped this ab to here. Okay. So a square plus ab plus bc plus ac. Now it is a new arrangement. So now we can take common. How to take common here? So from a square and ab, what is the common factor? That is a, because a square, what is present in a square? A into a. A square consists of a into a, and ab consists of a into b. Okay. So in both cases, what is present? A is present. So a is the common factor. So write here a into a plus b, because from AB, if A is common, then B is left. So plus from these two common factor, what is common? From BC and AC, what is common? So let's see. BC consists of what? B into C, and AC consists of A into C. So what is common factor here? That is C. So write C here. So if C is common, then what will take inside the bracket? That is definitely B. Plus from AC if you take C common, then what is left? That is A left. Okay. So A plus B and B plus A both are same term because common binomial factor that we have read in the last class. So A plus B and B plus A both are same. These are binomial factor, common binomial factor. So we have to arrange like this. We can write A plus B, that is the common binomial factor, into A plus C. What is left here? A and here plus C. So A plus C another binomial term. So A plus B into A plus C. That is the solution of this rearrangement. Next, look at this example here. P square q minus pr square minus pq plus r square. So what is common here? So here p square q and pr square, definitely here p is common, we can take all, otherwise we can rearrange it. P square q and pq, we see that most of the terms here literals are common, so rearrange it. So p square q and minus pq, make it one group, rearrange it, and another term, that is minus pr square and plus r square, make it another term, another group, equal to, so from p square q and pq, what is common? Definitely that is pq, because if you break it, p square q can be written as p into p into q, and pq how can write? pq can be written as p into q. So what is common here? So p is common in both the case and q is common in both the case. So what is common? PQ. So right here PQ is the common factor in both the case. So if PQ is common, what is left then? Here P is left, minus if PQ is common, then what is left here? 1 is left, because 1 into PQ is PQ. So right here 1 minus, then look at these two terms, PR square and R square. What is common here? Definitely that is R square. If R square is common, then what is left here? That is P. Then minus or minus will be plus, so put a minus sign here. Then here R square, so R square is common, then write 1 here. So now it is P minus 1. So it is a binomial factors. The common binomial factor is P minus 1. So right here p minus 1 is one of the common binomial factor, and p cube minus r square is another factor. So this is the solution of this rearrangement. Now from your book, the exercise 6c we are going to solve using this concept. Okay, so the first question, look at the first question. Here first question is given ax square plus by square plus bx square plus ay square. So from these terms we can rearrange it so that the common factor will get. So how to rearrange? Ax square and bx square can be rearranged because we see here x square is common in both the case. So ax square plus bx square. So it is one group now. Now plus by square plus ay square. It is one group because we see that y square and y square is common in both the terms, equal to. So we can take common now. X square and x square in both the terms it is present. So x square will be common. So x square if you take common, then what is left here? That is a. Plus if x from bx square if you take x square, what is left? That is b. Plus from by square and ay square, what is common? So here y square and y square in both the case y square is present. So y square we can take as common factor into, if y from by square y square is taken, what is left? That is b. Plus from ay square, if y square is taken, what is left? That is a. So we see here that a plus b and b plus a both are common binomial factor. So we can write like this. The common binomial factor are a plus b, because a plus b and b plus a both are same according to the commutative law, into x square plus y square here. So x square plus y square we can write. So this is the solution of this algebraic expression. Okay. Now look at question number 4 from exercise 6c. Equal to, see here, x cube and 3x square. It is common. So what is common here? X cube means x into x into x, and 3x square means 3 into x. So we see that x square is common in both the terms. So take x square common. If x square you have taken from x cube, so what is left? That is x, because x into x square will be x cube. Simply writing x means power is 1. So if base is same, already told, if base is same and it is multiplied, power will be added. That means x square into x to the power 1 is same as x cube. Plus from 3x square, if x square is taken, then what is left? That is 3. So we can write 3 here. Plus from 6x plus 8. What is common here? From 6 and 18, what is common? That is HCF is 6. We can, if you take 6 as common, because in 18 the 6 is a factor, so common factor is 6 here. So we take common as 6 as a common factor. So 6 into x will be 6x plus 6 into 3 will be 18, because 6 3s are 18. Now we see the common binomial factor, that is x plus 3 and x plus 3. So it is a common binomial factor. So you can write like this: x plus 3 as a common binomial factor into x square plus 6. X square plus 6 is another term. So this is the solution of this algebraic expression. Okay. Now students, look at this same exercise 6c questions. From exercise 6c, the one question is question number 13. It says that 6pn plus 9nq plus 8pn plus 12qn. You have to factorize these terms. Okay, factorize. So first of all, we will see the common factor. If it is not that, you have to rearrange it. That is the rule. So you see here 6pn and 9nq. Yes, it is common here. From 6 and n, we see that it can be common. So if 6 and n you find out the HCF, what is common? That is 3. Okay, that is 3 is common in both 6 and 9. So write here 3. And from P, M and NQ, what is common here? That is M. So here 3n is common. If you take 3n from 6 pm, so what is left? Because 3 into how much is 6? That is 2. So write here 2 and multiply here p, because p is present in this term, 2p. So that will be 3 into 2, that is 6, m into p, that is pm, plus 3 into how much is 9? Because if you divide 9 with 3, you get 3. Okay, then n is not common here, so what is left? That is q. Plus from here look at, see, from then with the plus sign, then from 8 pn and to 12 qn. So first look at the coefficient 8 and 12. So in this 8 and 12, what is the HCF of this? Definitely that is 4. 4 is the HCF of 8 and 12. So if 4 is common, then look at the literals now. From pn and qn, what is common? That is n. Right here n. So if you multiply 2 here and p, 2p, that means 4 into 2 is 8 and n into p is pn. It is same as 8pn. Plus how much? From 12, if you take 4, if from 12 you divide 4, what is left? That is 3. Write the coefficient 3 here. Then already n is common here. So what is left here? Q is left. So that is 2p plus 3q, which is same as here 2p plus 3q. Here also 2p plus 3q. Both are binomial terms, common binomial terms. So right here, if it is common binomial terms, right here 2p plus 3q can be multiplied with which term? That is 3m plus 4n. Right here 3m plus 4n. So this is the solution of this algebraic expression. Now look at this question number 15. In question number 15 say that factorize axy square plus 3x plus 2a square y square plus 6a. So look at the first two term. If it is common, then we'll take, otherwise we have to rearrange it. From x y square plus 3x, what is common? That is x. Yes, definitely x. So take x as common. Then if x is taken as common, then what is left? That is ay square. Ay square is left. Plus if from 3x, x is already common, so what is left here? 3. Because if you multiply 3 with x, the same value 3x will come. Then plus, look at the coefficient. Here 2 is there, here 6 is there. From 2 and 6, what is the HCF? Definitely that is 2. So right here 2. From a square y square and a, what is common? That is a. Right here a. So if you multiply this term, so 2 already common here, a already common. From a square, a is common, so 1a left and y square left here, so that is a y square. Plus from 6a, if 2a is common, then what is left? That is 3, because 2 into 3 is 6a into, that is a is common, so it is 6a. So we are getting here the common binomial factor, that is ay square plus 3 in both the case. So write the common binomial factor ay square plus 3 plus what is left here outside the common, that is x plus 2 is the common factor. So write here into multiply with x plus 2a. So this is the solution of this algebraic expression. Okay, that is ay square plus 3 into x plus 2a. Okay.